Mode shapes are a bit confusing, so let's put on like a conceptual hat and try to understand what mode shapes are. First of all, they are not the displacement of the system. They're not the displacements of the system. That's a common mistake to make, right? People like to think that, oh, mode shapes are the displacements of the system, right? No, rather they describe the configurations into which a structure will naturally displace at a given frequency, right? So let's consider let's consider a structure that looks like this. Originally it's just a vertical pole, like a light pole or a flagstaff, and it's fixed at the bottom. So that's what it originally looks like. And it's shaking dynamically in some amount. And so let's say it kind of looks like this, and the wind is blowing it. So it kind of moves over to the right? And that's going to be our structure. All right. We can take this model and measure it at different points. Let's do that here, 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 and here. And that's x1, x2, x3, and x4. And so these are displacements at 4 individual places along this beam. Now remember, mode shapes are not the displacements, right? But these x's, these are the actual displacements along my beam. Now, those displacements are equal to, let's say that is a system that can be expressed by the first 4 modes. So let's draw the first 4 modes of the system. The first mode, pretty simple, just looks like that. Right? That is what the first mode of a system looks like. And it's going to have a displacement here. We're going to call that U11. And we're going to call the position at the second spot U21. And the third, we're going to call that U31. And then this one here we'll call U41. That's my first mode. Now my second mode looks a little bit like this, right? And again, I'm going to have U12, U22, and now this 2 on the back side is the second 2 in the subscript, is telling you that this is the second mode. So it's my modal displacement at 0.3, my modal displacement U at 0.3 for my second mode, so U32, and then U42. Now I have the next mode, and the next mode adds another level of complexity, another curvature, and it's going to look something like that. And I have my fourth mode, and it adds another level of complexity, and it's going to look something like that, right? And so each mode shape adds a level of complexity. All right, let's think a little bit now about displacement. I said these aren't the displacements. That is correct. These are the U's. These are the modal displacements, but not the physical displacements. And now I can go ahead and write my displacements for these as x. In this class, moving forward, I'm going to write vectors as an x with an arrow on top. I do this because I like to use bold letters for matrices, and it's a little hard to do that in writing. But in the text, I can use matrix, and then I like to use arrows on top of the vector so we know it's a vector. X of mode 1, I'm going to zoom in a bit, is equal to Q1 U1 vector, where Q is my participation factor. How much of this mode participates in the displacement? And now I'll have x vector of mode 2, and that equals to my participation factor 2 u vector 2, and that's going to be x of mode 3, which is equal to my participation factor 3 u vector of 3, and that'll continue on for the fourth one. All right, a little bit of practical discussion here. In theory, and theory can be a very dangerous thing, really can be. If you give me a finite element model that has 10,000 points, I can get you the 10,000th mode of the structure. Does it mean anything? Good question. That's one of those questions kind of for you and your spiritual advisor. It doesn't mean anything physically, and it definitely doesn't mean anything in an engineering sense. The energy in a structure dies off kind of after 5 modes, right? If you want to capture the dynamics of a structure beyond mode 5, it's going to take some thinking. Not impossible, not hard, but it's going to take some thinking. Past 10, these are rules of thumb. Past 10 is hard, is, let's say, not easy. Let's go past 25 is hard. I don't even know what you'd be looking for past 25. And we're talking past 25. Good luck having a participation factor over 1%. I don't think you'd even make it to that. I have never seen anyone do experimental modal analysis past 50 or 100. I go to a modal analysis conference. I once heard I think I can use this term because they describe themselves this way, 2 old guys in the field talking about how one time they went up to almost the 100th mode shape, and I asked the question, why? And they looked me square in the eyes and they said, because we could. And I was like, is there any information up there? And they go, nope. But you know what? They sell modal analysis software, and they were able, they say, to get information at the 100th mode. I mean, they got information. Is it the 100th mode of the structure? I don't know. So something interesting to think about, and general discussion of mode shapes.